In the last video, we showed how to represent Newton's first law in NetLogo, and this is the code that we came up with. Newton's first law is that an object in motion will stay in motion unless acted on by an outside force, or another way of stating that is an object's velocity will stay constant unless acted on by an outside force. And so what we have here so far is we're creating a few turtles, as they're known in NetLogo. We've given them new variables for velocity, and we're starting them each with a random velocity. And then each time step, we just ask those turtles to update their position based on their current velocity. So the next position that this turtle will be at is the current position plus whatever the velocity is times the time step. So if it's 3 patches per tick, the world here is divided up into patches, and the time step is 0.1, so it'll move 0.3 patches in that direction. And so that's what this looks like. And now we're going to take the next step and represent Newton's second law, which is F equals ma. So here we have a constant velocity. Newton's second law is F force equals ma. But in this context, I think it's more useful to think about it as A equals F divided by m, meaning the acceleration is equal to the force, whatever the applied force is, divided by the mass. So the bigger the force, the faster the object is going to accelerate, meaning its velocity is going to change more quickly. And the bigger the mass, the slower it's going to accelerate given the same force. So the first thing we need to do is give each object a mass. So we're going to add that to these turtles' own. And at the beginning, we're going to, for now, we'll just give them each a mass of 1. And then instead of just updating the position based on velocity, we also now need to update the velocity based on the acceleration, which is really based on the force. So the first thing I'm going to do is move these two commands here. I'm going to make a new procedure called move just to make things easier to read. And so this is doing the same thing. It's just instead of doing it right here inside of this ask, we put the details in here where we say, okay, go ahead and move. They're moving based on Newton's first law here. And so that just, when we're reading this go loop, it's easier to read, okay, we're asking the turtles to move. Okay, how exactly do they move? And then we can go in here and look at that code. Okay, and then the other thing we're gonna do is ask them to accelerate. So to accelerate, and for now, I'm gonna leave that blank, but what we're gonna wanna do is have our turtles accelerate based on an applied force. So I'm also gonna initiate the velocities here to be 0, because we want them to then accelerate based on an applied force, and we'll start with just one turtle to keep things simple. Okay, so we've got one turtle, and if we click go, nothing will happen because the velocity is 0 and we're not doing anything to accelerate. So we'll start, I'm going to create a slider, and I'm going to call it Fy for force in the y direction. I'm going to have it go from -5 at an increment of 0.5 to a maximum of 5. We'll start it at 0. So now we have this Fy slider, and we can slide it back and forth. And so now inside of this accelerate, I'm going to do the same type of thing I did here for updating the y coordinate, but I'm going to do it to update the y velocity. So it's going to be the current y velocity plus, and now we need to use this acceleration equation. So it would be ay times dt, but we don't have anything called ay. What we do have is Fy divided by the mass. Okay, so now if we click setup and go, nothing will happen, but if I move this slider, now this object starts accelerating upwards. If I move it to be negative, this object will start slowing down and eventually turn around. Okay. If I do it really fast, it'll do it quickly. Strong force, do it the other way. And if we set it to 0, it will just stay at the same velocity. Now that's a little hard to see that it's staying at the same velocity. So let's do a couple things to visualize that. First, I'll make a plot. And what I'm going to do is plot the Vy of turtle 0. So this is going to be plotting the y velocity versus time. So it's starting here at 0. If I make it negative, we're going negative, positive, now we're going, it's increasing, it's not yet positive. And then when we turn this, when it turns around here, that's when we've now crossed to a positive velocity. So this is one way to visualize the velocity. And the other thing we can do is, which is quite common, is to have the turtle here draw dots. So I'm going to ask the turtle to draw a dot. I'm just defining a new procedure here. And there's something in NetLogo called stamp, where it draws a dot of itself wherever it is, but that's happening too quickly and these are too big to really be useful. So what I'm going to do first is set size to be really small, then stamp, and then set the size back to be 1. And maybe that was too small. There we go. That's happening too quickly. So now I want to just do it every 10 ticks instead of every tick. Right now this is happening every tick. So a way to do that is to use an if statement. If ticks mod 10, then we're going to do this. What mod does is it takes the remainder, it divides and takes the remainder. So if the ticks mod 10 is equal to 0, so that means if after dividing the ticks by 10, there's a remainder of 0, meaning every 10 ticks, then we're going to do this. So now it's only going to draw a dot every 10 ticks, and they're a little more spread out. It's easier to see what's happening with this acceleration happening in each direction. So this is the basics of Newton's second law, force equals mass times acceleration. We could, of course, add another slider here for in the x direction and do the same thing. And I'm going to go ahead and do that because there's one other thing here that's worth showing. So I'll do fx again. Increment by 0.5. Okay. And so we'll do the same thing here. So I'm just going to copy this, and then I'm changing the y's here to x's, so vx. Okay. And so now we'll see this thing go in different directions. And the one thing I wanted to show, in case you wanted to draw the path of this, so if we ask this turtle to set its pen down, then it's going to draw its path, and you'll see that it gets does a sort of staircase pattern. And the reason for that is it's drawing its path, and we're first updating the x coordinate, so it moves in the x direction, and then we're updating its y coordinate, so it moves in the y direction. So to avoid that, to make it look like a straight line, there's something called set xy, which does it simultaneously. So I'm going to cut this. You just give it first the x position that it's going to update. We can delete this. And then the y. So now we're doing the same thing. We're just simultaneously setting the x to be the current x coordinate updated by the velocity, and the y to be the current y coordinate updated by the velocity. And now this thing will draw a straighter line. Yeah, there's a little bug over here in the plots. In this, I'm using a beta version of NetLogo right now. So we'll get that dealt with. Okay, so that is the basics of Newton's second law, F equals ma, updating the velocity based on the force and mass, meaning acceleration is how quickly the velocity is changing. And so each time step, the velocity gets updated from what it currently is based on the current forces and mass. And in the next video, we'll move on to Newton's third law.